good morning, everyone, and thank you for the opportunity of being here and listening to me talking about ransomware and how to protect and recover databases. So ransomware is the topic, but the keywords I would like you to consider and to focus on is protect and recover. That's what we're gonna talk about. Cyber attacks today are really the next generation of business outages. Historically, data protection has always been focused about disaster recovery. Basically, what we were focusing and looking at hardware failures, disaster, natural disaster, power failures, those type of things where data loss of outages, IT issues were kind of a side effect of the problem. Now, cyber attacks are becoming definitely the largest security threats. And the point is that those attacks are really designed specifically to paralyze your IT environment and basically cause business outages. There are not only obviously financial, legal consequences, but also reputation problems. I have a short list here. There's news every day of ransomware attacks. The first one I have here is, University of California, San Francisco. They were attacked, where in a crypto locker, fashion, and all their research data were basically locked and made unavailable to the researchers and everyone. And they didn't have a good backup. They were not able to recover. They had to pay the ransom. And the reason why it made the news is that because it's a public university, so they were forced to publish in their report the fact that they were attacked, and also the fact that they had to pay $1.1 million for that to get their data back. Financial services are attacked, according to a report from Boston Consulting, 300 times more than other sectors, but no one is really in a safe position. All industries, all sectors, all type of companies are constantly attacked, and I have a little more here. The frequency of ransomware attacks is growing. We went from, according to this report for Broker, around one attack every 40 seconds in 2016 to one attack every 11 seconds in 2021. And again, there are a number of reports, right? Like the FBI, over 4,000 attacks every day that cost US organizations more than $7 billion in 2019. And the average cost to remediate this type of attacks is close to $2 million. The probably most staggering statistics about this is the average downtime, 19 days. Now imagine what it means to be for 19 days without access to your IT and tools that the company needs to make business, especially given what that's our main focus. Imagine if you are for 19 days without access to your databases. What even just a short outage of minutes can impact hundreds of thousands of transactions, which means lost orders. It means millions of dollars in damages. Imagine being out and not having access to your database for 19 days. And as I was saying before, it's not just a matter of healthcare and financial, which are usually considered the most targeted industries for ransomware, but really no one is safe. And the slides were also from Unbroken, and you have the links here if you want. You can go and read the reports. It's quite interesting. And no one is safe, and there are different type of attacks, and different type of attacks can have different effects on different industries. Some are more complicated or more damaging, but the point that I want to make here is that really no one is safe. So what happens? What are we really talking about when we talk about a ransomware attack? So there is nowadays a big change. Some also start calling this type of attacks really ransomware ransomware as a service. It's not the time anymore where it just was one laptop of one employee infected that clicked on an email or something and got just these local files encrypted and maybe a network share or something like that. Now attackers are really organized. So they are sophisticated. They are very, very good at what they do. And they really set up, some kind of command and control centers. And from there, they start their operation and they plan for their attacks, targeting and identifying the targets and what they're going to do. And now then they start, pushing out the type of attack vectors that they want to use. Again, normally it's just phishing emails, SMS. Software upgrades is something that's been seen a few times, where malware was embedded into a corrupted software upgrade. So customers downloaded an upgrade for a software they owned and installed it, and they were attacked in this way. Again, this is not just a simple malware. It's not just the CryptoLocker itself that comes with this. These malwares are really agents that are installed on the target computer, and from these command and control centers, they really take controls of these agents. And they can be sitting there for quite some time. And from there, they start usually credential harvesting. So they start trying to identify what type of users and passwords they can steal. And you wouldn't believe how many customers, and sometimes I have to say companies that are working and doing outsourcing and doing database management, for example, also for customers, just use Excel files with all the password of CIS users and their passwords on Excel files on the desktop of the laptop of the users that are there. So through these agents, once they can get access to that type of information, they start basically identifying what applications are used, what databases are there, what applications are there, what credentials they can get, and they start moving laterally. They start attacking specifically storage mount points, again, application databases, whatever they can get onto, with particular attention to backup systems. So they try to identify what type of backup system are you using. They know how to treat them. They know how to render them inoperable. Going to the point of deleting existing backups, rendering backup devices, all with the objective of preventing you from recovering, because they know that your last resort is restoring from a good backup. If you can restore from a good backup and you're not losing a lot of data, you can avoid paying ransom, and that's not what they want. So when everything falls in line and everything is done, obviously part of this process, as you are well aware, is also exfiltrating the data. They steal data because they also try to threaten you that, in case you try to ignore our request and try to restore from backup, but know that we have a copy of your data and we will publish it, and you may not be happy of having all your business data or your customer data out there on the internet. So they try to steal data and also have this second threat that they do. And they, when they're done, they send you a ransom request. So again, this is really a sophisticated process. It's not just a simple malware CryptoLocker that locks your data. And I was saying it takes time to do all of this. Happened, right, that again, from the same broker report, on average, the time to discover that the system were breached is around 197 days. So almost a year. that you had some, or customer had some agents and malware and people, criminals actually lurking and working on the systems, totally unknown. Obviously, the sooner you identify this, the lower is the cost of remediating, right? The companies that were able to identify this within 30 days, so identify a breach within 30 days, saved more than 1 million. Again, this is just statistics, but it's really to give you the perspective of how sophisticated this type of attacks are and how long it takes. So focusing on databases specifically, what can you do? And I want to mention this because, again, this is not the focus, but on Oracle databases, there's a number of tools, products, so additional products and features and tools that comes with the Oracle database that can help you discovering the breach as early as possible when it happened, and making the life of those criminals that are trying to do what I just described more complicated. Okay, so you have tools like TDE, transparent data encryption, encrypt your data, encrypt the data in your database, because again, there is the risk of exfiltration. So at this point, even if someone is able to access your database server and steal your database files, they will not be able to publish the data. They would not be able to find what's in there because the data is encrypted. You can use Oracle Key Vault, which is a key manager, to store the TDE encryption keys on an external secure server. So again, if the database server is attacked, the data are encrypted and the keys are not there. There are other tools like Database Vault, data reduction. Again, this is not the focus, so I want to really at this point give you, and I think Peter later will have something to say about this too. But give you the overview at all the tools that are there and the actions that you can take to assess, to identify what the situation is, to prevent attacks from happening, and also to detect them quickly, right? So you can use things like database firewall, for example, to filter all the SQL requests going into a database and be able to detect attempts to attack through SQL on your database, and obviously detect and report and store everything in data safe and audit vault where you can run reports. And again, all of this with the purpose of identifying as quickly as possible that a breach happened and to limit the risk of those side effects of stealing data. But again, that's not all. If you look at this, this is an example of the data security maturity model. The foundation is always data recoverability. The first thing that you should look at is make sure that whatever happens, you have a valid, secure backup of your data that you can restore quickly and that you can restore up to the closest point in time, right? Up to the closest time to the attack. So minimizing data loss, basically. So you're zeroing on minimizing data loss, restoring fast in a timely manner with minimal impact to the business, and with validated data, possibly maintaining a copy of your data in an isolated zone where it's even more protected. So that's what I want to focus on, and that's what we're going to talk. So if we put it back on the life cycle of the ransomware attack, if you want, that I showed you before, this is where we are. We are at the point where we want to secure backups. We want the attackers, first of all, not being able to compromise your backups, and we want to be able to have capture all the data up to the closest point in time to the attack. And then going back, there are the other things that I was mentioning, so TDE and security on hardened Exadata infrastructure, so having the database storage not accessible to everyone, for example, to protect your data using audit vault, firewall, or using the security assessment tool to make sure all the user accounts and privileges and role verification or roles are protected. You don't have unsecured users out there, etc. So all the things that you can do, and that again we'll not talk in more details now, but things that you can do to try to prevent the ransomware. But the point is, if it happens, if the attack happens, if it's successful, what can you do? And that's where the Zero Day Loss Recovery Appliance comes into place, providing exactly those features: the ability to have transaction level protection, the ability to be configured in a air-gapped architecture with a secure copy on a normally disconnected location, etc. And that's what I would like to talk a little bit more in the next minutes, all with the purpose of not paying the ransom, being able to kind of ignore the ransom requests and restore your data and recover and be safe. Also because those are criminals, so there's no guarantee that even if you pay the ransom, they will actually give you the keys to decrypt the data, because they don't care. All they care about your money, and that's what they want. So let me cover a little bit more details now, which is really the focus again: protect and recover the Zero Day Loss Recovery Appliance, and position it and describe how it is, a good solution to help in protecting from ransomware attacks. So we have three pillars, if you want, that you see here: recovery assurance, ability to have real-time transaction protection, real-time continuous recovery validation, and fast database restore. Resilient architectures with separation of duty user models, and I will talk more in details in a moment. Immutable backup policies, so you can make sure that no one can alter the backups, and you have the same hardened compute and storage service I was mentioning before for Exadata, because it's actually built on an Exadata platform. So the hardware is the same as an Exadata server and Exadata system. And it means that there is no access to directly to the storage of the recovery appliance. Its backups are not stored in an NFS mount location or something like that, where it's easy for someone to get access to the content of it. It can only be accessed through Armin. And the Cyber Vault architecture, the Cyber Vault deployment, where you can have an air-gapped copy that is normally disconnected from the network. So an additional copy of your backups that is actually not accessible regularly on the network. So let's go a little bit into more detail. So what it is, for those of you that are less familiar or never heard about the recovery appliance, again, it's a backup appliance that can be used to back up any Oracle database on any platform, and it provides real-time protection. So every block that is updated on an Oracle database is immediately transferred from the database memory to the recovery appliance. Backups are also done in an incremental forever fashion, so there's only the changed are copied, and they are very fast. Backups are then virtualized, so they are converted into virtual full backups in the recovery appliance. So when you do a restore, it's restored as a full backup. It supports immutable backup configuration, so you can configure policies that have a certain retention during which backup cannot be deleted or modified by anyone. As I was saying, it supports a Cyber Vault architecture, so it can be configured with a replica copy on a location that is normally disconnected. Most of the customers that are doing this through firewall rules. So they have tools that open the firewall ports to connect to the Cyber Vault only at certain intervals. That can be very short because you only transfer an incremental backup into the Cyber Vault, and then the virtual full is created on the Cyber Vault as well. and the archive logs, obviously that's what's going to be copied, and then the connection is closed and that copy is safe and it's validated locally, so you're sure that it's not tampered with by anyone. Backup can also be copied off-site to, for example, to archive storage in OCI, where you also can define immutable buckets, immutable policies, where you can create rules that make the content of the bucket, or make the bucket like a warm storage location where you can only write and not delete or update for a certain period of time. And you can also use ZFS storage appliance as an additional target, again, with the same immutable policies configured. And that can also be the first tab. In this example, you see it in the cyber vault, can also be outside of the cyber vault. You can configure it however you like. TDO encryption is supported across the whole life cycle. And the important thing is validation of the data. The data is validated at every step. I will get into more details in a moment. So let's talk about transaction level protection, what it means. So normally when you back up an Oracle database to a traditional destination, what happens is that you probably want to use a full and incremental backup pattern that is then intermixed with archive log backups. And what happens is that you can recover up to the last backup that you have. So after you back up your last archive log, you start having an unprotected window. You start having some time where you don't have any protection until the next archive log backup is backed up. So if you have an interval of, let's say, 4 hours between archive log backups, you potentially lose 4 hours of your data. So if you have a ransomware attack happening, you may end up losing, if you want to restore from such a a type of backup solution, you can lose up to 4 hours of your work. Right? With the recovery appliance, as I was saying, you have a real-time protection. Every single block update that happens on an Oracle database is immediately transferred to the recovery appliance. It means that you can recover really up to the last second before a ransomware attack happened. It means that you are not losing any data. You can recover and basically start going from the last transaction before the disaster happened. This is also important when you have multiple databases, because if you have multiple databases, you want them to be kind of synchronized, right? You want to be able to recover all of them to the same point in time. And if you have different archive log policy backups on different databases, you may end up losing even more time than what you have, just because for one of the databases you don't have the same time that you can recover exactly the same time as another one. So you have to go back a little more. With the recovery appliance, as I was saying, you can really go to the last transaction. So you have a total consistency that goes above all your database fleet, and it can recover really at the same time. The backups, as I was saying, are virtual. And what it means is that we use this incremental forever pattern. It means that only the first backup taken to a recovery appliance is a full backup. And after that, for the life of the database, you are only taking incremental backups. So on day one, you have your, obviously, day one backup, which is the full. On day two, you back up only the changes, and only the changed blocks are sent to the recovery appliance. So the backup is short, is very fast. And inside the recovery appliance, a virtual full is created, combining the blocks from the previous day with the blocks of, so the blocks from the full, day one, with the blocks that are changed on day two, and this virtual full is created. There is no merge process, there is no data movement here. It's just a kind of set of virtual pointers creation, and you have your full backup representation for day two. And this keeps going forever. There's no need of taking a full backup anymore. And this allows us to have very fast backups. It also means that, again, when you use a cyber vault replica, you are only transferring the changes, so only the incrementals to the cyber vault. So the cyber vault can be open always for a very short period of time, where the incremental plus some archive logs are transferred, and then it can be closed. The firewall can be closed again. The virtual full, so this same process happens also in the cyber vault. The other advantage of this is that when you want to do a restore, you're always restoring a full backup. You don't have to worry about restoring a full and then do the recovery through all the incrementals, because for every incremental backup you send to recovery appliance, you have a virtual full backup at that time. Okay, so then you can restore to any time that you have protected. The other important topic that we're going to talk about is validation. The recovery appliance knows what an Oracle block is. It means that validation is not just based on a simple kind of storage block in an agnostic fashion validation, but it's really done at the Oracle block level. And Arman also does the same type of validation. It means that if a ransomware attack, if any type of attack happens on an Oracle database that tries to tamper with Oracle data, because again, we just use Arman to transfer the data to the recovery appliance. So we only move Oracle blocks. And if anything happens, and any attempt to tamper with the Oracle data would be detected by Arman, because an invalid Oracle block would be detected. So the backup would be blocked. So if something happens on the database and we want to entertain the idea that someone can try to tamper with an Oracle data on a database server, that data is not going to reach the recovery appliance because Arman would block it. It would be detected the moment Arman tries to read the block. If we assume that we want to consider the idea that something may happen in transit over the network when the data is transferred to the recovery appliance, the same thing happens when the data are received, because when the recovery appliance receives the backup data, it actually opens the backup file that Arman sent, and it indexes all the blocks and validates all the blocks. And if an Oracle block has invalid data in it, it would be detected. So if we want to assume that anything happens either in transit or on the recovery appliance, it is detected because it would fail the validation. And the same thing happens at every step. When it's copied to a ZFS destination, to a cloud, again, data movement is done in the same way and data is validated again. Similarly, on the cyber vault, the data is validated when it's transferred and when it's received on the replica appliance in the cyber vault. So this also means that we don't need in the cyber vault complicated architectures, including database servers, to do validation of the data in the cyber vault, because the validation is done by the recovery appliance itself. So if the data is there, it means that it's valid and it's good. In terms of separation of duty, what does it mean? It means that you can have DBAs, database administrators, that take care of the databases only. It means that they can initiate backups, they can initiate restores of the databases, but that's it. They have no access to the recovery appliance. And also the recovery appliance can be configured in a way that Arman delete commands are rejected. So the DBA would not be allowed to run an Arman delete backup command to delete specific backups. The recovery appliance is managed by recovery appliance administrators. The recovery appliance administrators define the policies on the recovery appliance that determine for how long a backup must be kept. So what is the retention on the recovery plans? And this is not controlled by the DBAs, it's controlled by the recovery plans administrators. Similarly, recovery plans administrator in the cyber vault, the recovery plans in a cyber vault can have a different recovery plans administrators, so different users, different personas, and these limits even more the ability for someone to steal the credentials of DBAs, for example, and log into Orban and do a delete backup command and delete all the backup for a certain databases, because it would not work. At the same time, if someone was able to find the credentials of a recovery appliance administrator, may do something on one recovery appliance, but not the other one, and also not have access to the databases directly. So it, the process I described before, through which there's criminals try to move laterally across different systems, becomes a lot more complicated. Okay. There are also immutable backups that can be configured. So the recovery appliance administrators can set, in addition to the recovery window goal, which is the goal, and it's the retention time that is configured for recovery appliance, an immutable window. It means that there is a period of time during which no one can ever change the retention for those backups. An administrator can change the policy and reduce that, but the backup that were taken when like in this example, the immutable windows of 60 days will live there for 60 days, no matter what. Similarly, a different policy, but with the same concept, can be configured in the Cyber Vault and also on OCI buckets, where you can attach what it's called the retention rules, or retention rule on a bucket, making it, as I was saying before, a warm type bucket, and you can set whatever type of retention. Can be 7 years, like the example, which is more kind of regulatory compliance type of retention, or it can be just, 7 days or whatever. It's considered usually shorter just for ransomware protection. So making sure that even if someone can get access to the bucket where the backups are located, it would be impossible to delete them, because the actual cloud infrastructure would prevent that from happening. When backups are sent to the cloud, as I was saying before, it can be also for compliance reasons, not only, but in that case, it's more a kind of long-term retention type of backup that is sent there. And it can be stored both in standard tier or in the archive tier, which is more cost effective, and it eliminates the needs for tape vaulting. So if you have the requirement of storing backups offsite and keeping them for a long period of time, you can do that, sending them from a recovery appliance to the cloud. And those backups sent to the cloud are in standard ARMAN format. It means that they can be restored directly without a recovery appliance. So if you assume that you may lose your data center completely and recovery appliance is not available, you can still restore just using ARMAN, the backups that are in the cloud buckets, and they can also restore into cloud instances directly. So if you do it for compliance and you need to be able to restore for just accessing some old data or whatever, for auditing purposes, you can spin up an instance in the cloud, restore into the database cloud service or Exadata cloud service, whatever, restore the database there, use it for whatever you need, and then you can destroy it and not pay for it anymore. All the backups in the cloud are encrypted. Encryption keys are stored in Oracle Key Vault. And again, buckets, I think this the third time I'm saying this already, buckets can be configured as regulatory compliance buckets, so with retention rules preventing deletion. So before closing this, I wanted to mention a few more things. One and a couple of examples of what customers are doing. This is a large global financial institution, global bank. They've been using the recovery plans for some time. They have a quite large environment. A lot of databases. You see 8,000 or more databases, 18 petabytes of backup. But they recently started using a kind of cyber vault configuration with a replica recovery appliance, and also using traditional tapes or moving data and copying data to tape for an additional layer of protection. They saw, their backup and recovery operation improve and being 4 times faster now. And about savings, that's the other thing that I wanted to mention. I think someone should be able to post the link here, but otherwise when you get the slide, you'll be able to find it. There is an interesting report from IDC specifically on the business value on the recovery appliance, and they did a nice exercise. They interviewed customers, etc., and they found out that there's an average 6-month payback, 4 times faster backups, 5 times faster recoveries, and 100% RPO. This is quote one of the customers they interviewed, right, about the improvement of efficiencies on the backup, right? They went to 20 hours once a week, and they're now down to minutes in terms of backing up the databases. So to summarize this before handing it back to Peter, I hope I didn't take all the time. Ransomware breaches can be devastating. I think we all agree on this. There's no material impact on revenue and also on trust and reputation of the company. Attacks are increasingly complex and sophisticated, and they become more complex and sophisticated by the day. So this type of problems require a modern data protection solution. Data protection is, as I was saying before, a pillar and the foundation, if you want, of ransomware protection. It just goes beyond traditional backup and recovery, and you need to include into this also the integrity and availability of your databases. And for this, the recovery appliance is the world's best. Oracle data protection is designed by the same team, the design Armand, so that obviously owns everything around protecting and recovering an Oracle database. It has recovery assurance. It has a resilient architecture, can be deployed in the cyber vault, and it's deeply integrated with the Oracle database. Thank you.